All right, so in this section, we talk about what we call sum and difference identities, right? And we use these when you've got sine or cosine or tangent of a sum, right? Sine of a sum of two angles, cosine of a sum or a difference of two angles, right? That's where sum and difference comes from. Now, so take a look. They kind of look similar to each other, right? With the two angles. Now, if you write these, like you see how in this box cosine is first and then sine? If you write them with sine first, so sine A plus B. So look, you have A and B, right? The book uses alpha and beta, which are the Greek equivalents. So look, it's sine A cosine B plus cosine A sine B. Okay, what do you notice here? You see how inside you have A plus B, A first, then B? After the equal sign, it's A, B, A, B. So that order is like it stays, right? Now, if you have cosine, yeah, and I'll make it a little bit bigger too. Cosine A, cosine B, minus sine A sine B. So regardless of whether it's sine or cosine inside, the order AB is preserved. AB, AB, AB. Okay. Now, what else do we notice? When it's sine, right? If it's a plus here, the plus stays. For the cosine, it switches. Okay? Now, there's actually a sum that goes like this. If you write it in this order, right? It's, you guys know, like, okay. So it's sine, cosine, cosine, sine, cosine, cosine, sine, sine. And that's how we remember it, pretty much. It's nothing different. It's literally the same things, but to a tune. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Right? Right. So if you have sine, we know it's sine, cosine, cosine, sine, and then the other one is cosine, cosine, sine, sine. So we're going to use that, and then, it'll help you out. Now, one other thing. If this is a plus, then it's a plus. If it's a minus, then this becomes a minus. So you can condense it like that. If this is a plus, that's a minus. If it's a minus, then it's a plus inside. Okay? The one I don't have a song for, but people don't actually, nobody has trouble with it. Trust me, like if you use it as many times as we're going to use it, it just kind of sticks. So for the tangent, look, it's tangent of this plus tangent of that. And then 1 minus tangent, tangent. And even though it looks very complicated, like I said, students really don't have trouble remembering it, okay? Okay, so how do we use this? And why do we use it? The reason why we use it, let's focus here, can we? Yeah, thank you. The reason, okay, the place where we can use this is, we've now learned how to evaluate trig functions. We've now learned how to find trig functions, evaluate trig functions for the special angles, right? 30, 60, 45, 225, and so on. But what about all the other angles, like 75, right? How do we do that? Well, this is one way that we can find, like sine of 75. So let's see how. If you take an angle, and if you write it as a sum or difference of two special angles, then you can use these identities to evaluate them. So that's what we're going to do. So look at sine of 75. 75 is not a special angle, but we can write it as 45 plus 30, right? So why don't we go ahead and do that? I'm actually going to do 30 plus 45, just because. So so this is going to be sine of 30 plus 45. Now, one of these becomes A and the other one becomes B, or alpha and beta. Let me do this and then I'll take questions, okay? All right, so what we have now is sine of a sum, right? Since it's sine, the expansion is going to be sine, cosine, cosine, sine. So that's how we're going to do it, right? So this is going to be sine, and then the order of the angles just stays. Sine, cosine. You just have to remember that if it's sine, the plus will stay. So sine, cosine, cosine, sine. Now look, I've just got sines and cosines of the special angles, which I totally know how to do, right? So sine of 30 is what? You all know. What is it? 1/2. 1/2. Cosine of 45, 1 over root 2. Cosine of 30, now look, if sine of 30 was 1/2, then cosine is going to be the other one, root 3 over 2, right? And sine of 45, 1 over root 2. Okay, next, this is 1 over 2 root 2 plus root 3 over 2 root 2. And all together, look, they have the same denominator even. 1 plus root 3 over 2 root 2. That's it. Now, when you go and check your answers in the book, they're going to look different because your book rationalizes all of these denominators, but I don't ask you to do that, right? So it might not look exactly the same, but you'll see now that there are only like a couple of versions of the same thing that you're going to get. So, you know, you'll figure it out quickly, okay? All right, did you have a question before?
No.
That's what I thought. See? Yeah.
So, like, okay, so you're trying to, like, find numbers that, like, go in the unit circle.
Yeah, just the special angles. Okay, so now, how do we do it in radian? First of all, we have two problems here. One is the angle is negative, but we're going to use our identities for negative angles, right? For negative theta. We know that sine of negative theta is what? Negative sine theta, right? The negative comes out, right? If it's a sine. So we can rewrite this as negative sine 7 pi over 12. Okay, now, how to do this? Sometimes it could be tricky, right? Because you have to have two angles like pi over 3, 3 pi over 4 that add up to this. So sometimes it could be tricky, but here's how I do it. This is negative sine of, I want two fractions. And you see how the denominator is 12? I put the 12. Now, what I want are two numbers here that are going to add up to 7 pi. However, when I put them here, they have to reduce to special angles. So for example, what's one way that adds up to 7? 1 and 6, correct? So I could do 1 pi and 6 pi, but does the 1 pi over 12 reduce to a special angle? No, so I don't want to use that one. So I always go like methodically. I don't just do random numbers. 1 and 6 doesn't work. How about 2 and 5? Will that reduce? No. 3 and 4? Yeah, that's a good one. It's actually kind of fun. So those of you that are going to Africa, I mean, like, what more fun way to pass all that time? Right? Just do a sheet of these. Yeah? That's what I would do. No, on the plane. I'm talking about the plane. Right? I know. That's what I'm talking about. Okay. So negative sine pi over 4 plus pi over 3. Okay. So it's sine again, right? It's sine again, so it's sine, cosine, cosine, sine. Negative out here, sine, cosine, cosine, sine. Okay? Sine, cosine, cosine, sine, right? And now we know all of these. So this is negative. What's sine of pi over 4? Right? Or 1 over root 2 times cosine of pi over 3? 1/2. Plus cosine is 1 over root 2. And now look, if cosine of pi over 3 was 1/2, the sine is the other one, root 3 over 2. So this is negative. This will be 1 over 2 root 2 plus root 3 over 2 root 2. And yeah, I'm putting in more steps than people at this level usually need. You know, eventually we'll condense all this. So this is going to be, okay, it's going to be negative 1 plus root 3 over 2 root 2. Now let's talk about negatives for a little bit. You can write it like this. Or you can distribute the negative and you can write it like this. Or you could just have the negative out here and write it like this. Any of these are okay. Okay? Yep.
Why did we put it in brackets earlier?
Why did or didn't? Huh?
Why did we put it in brackets rather than parentheses?
To make it more pronounced, I don't know, it's choice.
It doesn't matter.
Usually, I mean, yeah, it doesn't matter, but like convention is you start with parentheses and then switch to brackets and whatever, but it doesn't matter. Okay, other questions? Yep.
How do we know that it's a positive? The pi over 4 plus pi over 3 is not negative.
In here?
Yeah.
Because I wanted two angles that made 7 pi over 12, right? So I chose, okay, let's take, you could do either, let's just put it that way. I just chose two angles that would add to it. Okay. You could do two that subtract to it. It doesn't really matter. Okay, yeah.
So what's the difference between like that first one there and the third one? Like those are the same.
They're the same except this has the parentheses and these doesn't. It really doesn't matter which one, you know, they're all the same. I would like for you to recognize that these are all the same because at a later time, right, if you're ever taking a multiple choice test, like on the AP test, you don't know which version your answer will be in. So you should just be woke enough to recognize that they're all the same, okay?
Is it 2 and 3 on the bottom or 2 and 2?
2, it's 2.
Oh.
I got carried away with the 3s. Okay, so take a look at the next one. The next one, right, I have something else. I have like an expansion of something. So look at these identities, right? The thing about identities is one side is equal to the other side, right? So just like I can say 3 plus 7 is equal to 10, I can also go the opposite way and say 10 is equal to 7 plus 3, correct? So just like I can use these identities to go from here and expand this way, I can also go that way. So look at that one over there. What does it look like from here? Where do you see that? The tangent here, right? So this is what you're given, and now you got to go the other way. So let's see. Okay, so now you have to say, is it the plus or the minus, right? So let's see. You have to remember that the tangent identity maintains its positive negative in here, right? So if it starts off with a minus, it's a minus here, plus here. So don't look at this sign, look at the one on top. So this is going to be this one. The angles here are A and B. So all this is just equal to tangent A minus B, which is equal to tangent 78 minus 18, which is tangent of 60, which root 3. Okay, so you got to go all the way and simplify. Okay, what do we have here? What's this mess? So it's important that you again recognize I've got cosine, cosine, sine, sine. This, something similar is gonna show up next lesson. So you have to watch for the pattern, cosine, cosine, sine, sine, and also look at the angles. AB, AB, okay? Right? So this is gonna be cosine of what?
7 pi over 8 minus b.
Right, 7 pi over 8 minus 5 pi over 24. And then you have to do the common denominator. 21 pi over 8 minus 15 pi over 4. This is cosine of how much? Is it 16?
I think you worked the like I think you went down.
Oh, sorry. This is, sorry, hang on. This is 5 pi over 24. Sorry, my mind was somewhere else. 21 pi over 24, 5 pi over 24, so 16 pi over 24, right? Right? Cosine of 2 pi over 3, which is how much?
Negative 1 over 2.
Negative 1/2.
Wait, it would be 2 pi over 3. It'd be 1 over 3.
So it's 16 pi over 4, right?
Yeah.
So, and then divide by 8. So it'll be 2 pi over 3. It's 16 pi over 24, right?
Yes.
Yeah. Negative 1/2. Yeah. Okay.
Wait, I have a question.
Yep.
So how do you get that, the cosine and then like the minus? Because they're just adding the, like how do you know the cosine of?
Okay, because what you have up there is cosine, cosine, sine, sine. And then you look at the pattern for where you have cosine, cosine, sine, sine. And that's this one, right? Cosine, cosine, sine, sine is this one. Okay, let's move on. Okay. Okay, let's move on. Take a look at this. I have cosine of this mess. So let's see what we can simplify. All right? How much is this? Arc sine of root 3 over 2. How much? Right. Inverse sine of root 3 over 2, which is?
Oh no, it's
For what angle is sine root 3 over 2? Pi over 3. Okay. So now, and then what's this one? Arc cosine of x, right? So what is it that we have here? I have cosine pi over 3 plus inverse cosine of x, right? I just simplified it. I just rewrote it. Okay, now look, I have cosine of a sum, right? So since it's cosine, it's going to be cosine, cosine, sine, sine, right? So it's going to be cosine minus sine. Yeah. Okay? So cosine, cosine, sine, sine. And then remember, first, second, like that is preserved. Okay. Well, because that's what you have here. Arc cosine is inverse. Right, I just wrote it out right now. Now I'm going to simplify. Okay, so now cosine of pi over 3, 1/2. This is just x. And again, if you can see these right off the bat, right? You don't have to write out the whole thing, right? I'm doing a little bit more. I'm putting in more steps because it's our first time. Minus sine of pi over 3 times, okay, how are we going to do this? Remember, this was its own problem in the last chapter. Inverse sine of inverse cosine of x. We start from the inside, remember? Inverse cosine of x says there is a mystery angle in a right triangle, the cosine of which is x. If the cosine is x, it's x over 1. You guys remember this from last chapter? So how much is this going to be? Square root of 1 minus x squared. So how much is the sine of that angle? 1 minus x squared. Okay? Yep. It just got elevated another level, right? From the problem before. Okay. So x over 2 minus, this has a denominator of 2, and if you have 2 roots, you can multiply the insides. So this is the square root of 3, 1 minus x squared.
Shouldn't there be parentheses around the 1 minus x? It's like, it's not x squared, it's like 1 minus x parentheses, then it's just,
I don't see where 1 minus x squared inside. If it's in the square root, it doesn't matter. So now, in one fraction, it's x minus root 3, 1 minus x squared. You can, but it's not necessary. Okay? So that's what we have there. Okay. So we're going to do another one. Yeah. Okay? So the higher up you go, the more, the answers just become like mathematical expressions, right? Okay, let's do another one. Okay? Yeah? Let's do another one. Okay. This time, okay, again, we're going to go step by step. Now that we know, we're going to go step by step. Okay. Go inside the parentheses. Arctan of x. Let's just write it in simple terms like this. Okay? Arc cosine of a half. You want the angle for which cosine is a half. Which angle is that? For what? Pi over 3. Right? Because the sine of pi over 3 is root 3 over 2. Okay, so let's just rewrite this. Sine of inverse tangent of x plus pi over 3. Now look. Oh, minus, sorry. Now this is A and this is B. Okay? All right? So now, I've got a sine. So this is going to be sine, cosine, cosine, sine. Okay? Sine, look up here for a minute. Sine, cosine, cosine, sine. All right? So sine of the first, cosine of the second. Okay? Now, plus or minus? Plus, because for the cosine it switches.
But it's sine.
Oh my god, it's sine. I'm so sorry. Sorry. So sine, cosine, cosine, sine.
and how do you know that one's the sine? Oh, I see. Oh.
Okay. Let's see. This is sine. A minus B. In here I'm going to have sine, cosine, cosine, sine. Inside of them I've got A, B, A, B, A, B. Okay? All right. Now I'm going to go term by term. This one, I have to do a triangle. I have an inverse tangent of theta. Inverse tangent x, right? So here's an angle. The tangent is x. So opposite over adjacent is x. So how much is the hypotenuse? 1 plus x squared, or x squared plus 1, okay? So for the hypotenuse, we add them. Okay, so this one is the sine. Sine of this is opposite over hypotenuse. So let's do that.
Oh, I see why you just didn't swear the one needed to be the same either way.
Okay, times. Let me see if I can color code this. Cosine of pi over 3.
So it's just 2 root
1 half. Right. Minus this one. Now it's the cosine of that same setup. Here, cosine of this setup, 1 over, okay? And then lastly, this one, sine of pi over 3 is root 3 over 2. Okay. Look, denominator here is 2 times the square root. Denominator here is 2 times the square root, so they all have the same denominator. And then in the numerator, I have x minus root 3. Okay, so that's all. Huh? Yeah. Okay, any questions? Verifying. So this says verify cosine of inverse theta is equal to cosine of theta. Verify sort of means, just illustrate and show and prove and so on. Remember, this is an identity, right? It's like the negative angle identities, right? Yeah? Okay, so it's like, okay, somebody tells you, by the way, cosine of negative theta is just cosine of theta because the cosine engulfs the negative. And we use the unit circle to like illustrate it. But now, how about doing it algebraically? So what we want to do is this. And okay, before everybody, starts to react over, oh my God, I would have never known how to do that. This is why we're learning how to do it, because I wouldn't have known how to do it either until my teacher told me how to do this one. Okay? So the trick is you can actually use sum and difference identities to do this one. What we're going to do is we're going to work just on the left-hand side, right? Do some things to it and see that, after we work through it, our answer is going to be what's on the right-hand side. So the trick that you do for this, and you only know after somebody tells you what to do, you write the negative theta as a difference of two angles, right? So this is going to be cosine of, what's one way to get a negative number? Like, how do you get negative 3? You could just do 0 minus that number. So I can just write this as 0 minus theta. Again, the first time you never know how to do it until your teacher tells you. Now, I've got cosine of a difference. So this is cosine, cosine, sine, sine, right? So I'm going to do cosine of 0, cosine of theta, plus or minus, sine, sine. Okay, cosine, cosine, sine, sine, 0 theta, 0 theta, 0 theta. Now, what's cosine of 0? 1. So this is just 1 times cosine of theta. Plus, what's sine of 0 these days? 0. So this is 0 times sine of theta. So this whole thing goes away, right? It's just 0. So what do I have left? Cosine theta. Oh my God, that is totally equal to cosine of theta, the other side, right? So this is how we verify, okay? This is what section 2 was, but with like much more complicated stuff like the stuff we did in section 1. But we skip it. But for these for the actual identities, I like to do them because they're kind of fun and they're very short, okay?
Wait, so why does the 0 times sine theta go away?
Because 0 times anything goes away. Okay, we're going to do one more. Okay, and then we'll stop there. So why don't we're going to work on the left-hand side. Why don't you go ahead and expand. Okay, what goes away here? Cosine pi over 2 is 0. So you can just say, okay, this whole thing goes away because it's 0. So then I'm just left with sine of theta times what's sine of pi over 2? 1. And that equals sine of theta. Isn't that cute?
Wasn't that a minus? Wasn't there something
Okay.
minus?